LCM-LoRA, a Universal Stable Diffusion Acceleration Module. Latent Consistency Models, LCMs, have achieved impressive performance in accelerating text-to-image generative tasks, producing high-quality images with minimal inference steps. LCMs are distilled from pre-trained latent diffusion models, LDMs, requiring only approximately 32 A100 GPU training hours. This report further extends LCM's potential in two aspects. First, by applying LoRa distillation to stable diffusion models including SDV1, 5 SSD1B and SDXL, we have expanded LCM's scope to larger models with significantly less memory consumption, achieving superior image generation quality. Second, we identify the LoRa parameters obtained through LCM distillation as a universal stable diffusion acceleration module named LCM-LoRA. LCM-LoRA can be directly plugged into various stable diffusion fine-tuned models or LoRas without training, thus representing a universally applicable accelerator for diverse image generation tasks. Compared with previous numerical PFOD solvers such as DDIM, DPM solver, LCM-LoRA can be viewed as a plug-in neural PFOD solver that possesses strong generalization abilities. Project page, the project's website. LLaVA-Plus, learning to use tools for creating multimodal agents. LLaVA-Plus is a general-purpose multimodal assistant that expands the capabilities of large multimodal models. It maintains a skill repository of pre-trained vision and vision language models and can activate relevant tools based on users' inputs to fulfill real-world tasks. LLaVA-Plus is trained on multimodal instruction following data to acquire the ability to use tools, covering visual understanding, generation, external knowledge retrieval, and compositions. Empirical results show that LLaVA-Plus outperforms LLaVA in existing capabilities and exhibits new ones. It is distinct in that the image query is directly grounded and actively engaged throughout the entire human-AI interaction sessions, significantly improving tool use performance and enabling new scenarios. Prompt cache, modular attention reuse for low-latency inference. We present prompt cache, an approach for accelerating inference for large language models, LLM, by reusing attention states across different LLM prompts. Many input prompts have overlapping text segments, such as system messages, prompt templates, and documents provided for context. Our key insight is that by pre-computing and storing the attention states of these frequently occurring text segments on the inference server, we can efficiently reuse them when these segments appear in user prompts. Prompt cache employs a schema to explicitly define such reusable text segments, called prompt modules. The schema ensures positional accuracy during attention state reuse and provides users with an interface to access cache states in their prompt. Using a prototype implementation, we evaluate prompt cache across several LLMs. We show that prompt cache significantly reduced latency in time to first token, especially for longer prompts, such as document-based question answering and recommendations. The improvements range from 8x for GPU-based inference to 60x for CPU-based inference, all while maintaining output accuracy and without the need for model parameter modifications. GPT-4, all an ecosystem of open-source compressed language models. Large language models, LLMs, have recently achieved human-level performance on a range of professional and academic benchmarks. The accessibility of these models has lagged behind their performance. State-of-the-art LLMs require costly infrastructure, are only accessible via rate-limited, geo-locked, and censored web interfaces, and lack publicly available code and technical reports. In this paper, we tell the story of GPT-4all, a popular open-source repository that aims to democratize access to LLMs. We outline the technical details of the original GPT-4all model family, as well as the evolution of the GPT-4all project from a single model into a fully fledged open-source ecosystem. It is our hope that this paper acts as both a technical overview of the original GPT-4all models, as well as a case study on the subsequent growth of the GPT-4all open-source ecosystem. On the road with GPT-4v, ision, early explorations of visual language model on autonomous driving. The pursuit of autonomous driving technology hinges on the sophisticated integration of perception, decision-making, and control systems. Traditional approaches, both data-driven and rule-based, have been hindered by their inability to grasp the nuance of complex driving environments and the intentions of other road users. This has been a significant bottleneck, particularly in the development of common-sense reasoning and nuanced scene understanding necessary for safe and reliable autonomous driving. The advent of visual language models, VLM, represents a novel frontier in realizing fully autonomous vehicle driving. This report provides an exhaustive evaluation of the latest state-of-the-art VLM, model name, and its application in autonomous driving scenarios. We explore the model's abilities to understand and reason about driving scenes, make decisions, and ultimately act in the capacity of a driver. Our comprehensive tests span from basic scene recognition to complex causal reasoning and real-time decision-making under varying conditions. Our findings reveal that model name demonstrates superior performance in scene understanding and causal reasoning compared to existing autonomous systems. It showcases the potential to handle out-of-distribution scenarios, recognize intentions, and make informed decisions in real driving contexts. However, challenges remain, particularly in direction discernment, traffic light recognition, vision grounding, and spatial reasoning tasks. These limitations underscore the need for further research and development. The project is now available on GitHub for interested parties to access and utilize. Project's website: u-LLaVA, Unifying Multimodal Tasks via Large Language Model. Recent advances such as LLaVA and Mini-GPT-4 have successfully integrated visual information into LLMs, yielding inspiring outcomes and giving rise to a new generation of multimodal LLMs, or MMLMs. Nevertheless, these methods struggle with hallucinations and the mutual interference between tasks. To tackle these problems, we propose an efficient and accurate approach to adapt to downstream tasks by utilizing LLM as a bridge to connect multiple expert models, namely u-LLaVA. Firstly, we incorporate the modality alignment module and multitask modules into LLM. Then we reorganize or rebuild multi-type public datasets to enable efficient modality alignment and instruction following. Finally, task-specific information is extracted from the trained LLM and provided to different modules for solving downstream tasks. The overall framework is simple, effective, and achieves state-of-the-art performance across multiple benchmarks. We also release our model, the generated data, and the code base publicly available.